Welcome to another episode of This Is My Architecture. I'm Arthi, a solutions architect from AWS, and I have here with me Ryan from Know What's Loved. Welcome, Ryan.
Thank you.
So can you tell us a bit about what KWL does?
We are a data analytics company. We specialize in the music industry. We track and analyze data about music, such as music consumption, artist popularity, fan activity. We ingest data from thousands of data sources, structured and unstructured.
Great. So if I wanted to know who's the next big artist, I can come to your site.
That's what we hope to be able to do.
Awesome. Great. So could you walk us through this architecture you have here?
Sure. So what we have here on the board is our data pipeline for our metrics. And this data is collected on a daily basis. So every day we have a job scheduler that pushes all the jobs for the day into SQS, and each job could represent something like go to this artist's social media sites and collect the fan base data, for example, or go to this blog and retrieve the new articles on the blog. So we have a fleet of workers that would be launched automatically on a daily basis, and they will retrieve these jobs from SQS and then go out and collect the data.
So your workers are mostly scraping data from external sites?
Scraping and calling APIs as well.
Awesome. And then they insert the data back into your SQS queue.
That's right. So it goes back into a results queue, which is consumed by a separate group of workers, which may do some further processing. Like, for example, if it was a blog article, it will go through natural language processing. And after that, the results are saved into S3.
OK. So in case of SQS, have you ever faced restrictions with the message sizes? Because when you said you're scraping data, sounds like it could be a considerable amount of data. Or do you actually chop your messages before writing them into SQS?
No, we did not face a constraint. The limitations were well within our usage.
Okay.
Yeah.
Awesome.
Yeah.
So then what happens next once the data is in S3?
Yeah. So we have we use EMR, right, to convert the data from S3 into a Parquet format, and that gets saved back into S3.
Okay.
Right. So what this does is that it makes it really easy and really efficient for us to put Athena in front of this, and in order to query the data that we have, which is our data lake. So.
So the Parquet format sort of minimizes the amount of data you need to scan when you use Athena.
That's right. I mean, in terms of performance, in terms of being able to express our queries in simple SQL, it was a really big help.
Okay. And then what happens to the data next?
Right. So we leverage on Athena heavily. So we have ETL servers that works together with Athena, right, to process a lot of data. And then these process metrics and scores will be saved in Aurora, which is our data warehouse. And this is where the data will be consumed by our users on the dashboard.
OK, so this is Aurora Postgres?
That's right, Postgres.
So just out of curiosity, why did you not choose a more data warehousing solution like Redshift, and why Aurora as your data warehouse?
Well, both Aurora and Redshift are great solutions for data warehousing requirements. They have some relative trade-offs with each other. So Aurora, for example, has more flexibility in terms of auto-scaling and in terms of being able to update data easily, whereas Redshift, in terms of raw performance, there is a tremendous potential with the columnar store feature. But we decided that we needed flexibility more than raw performance at this point. That's why we chose Aurora.
Great. And what about Elasticsearch here? How does that help?
Right, so Elasticsearch drives two key features on our dashboard, which is our artist search feature, as well as the newsfeed feature. So what we do is we have these same ETL jobs will process the search indexes by taking data from Aurora, and these will be used to power again features on the dashboard.
Awesome, that sounds great. So what do you think have been some of the key benefits you've realized by building this on AWS?
Well, the biggest benefit is that a lot of these are managed services. This is a managed service, this is a managed service, so are this, and this, which means we never had to go figure out how to build it by ourselves and to manage it.
Sounds great. So what's next for KWL?
We have a couple of areas. First is machine learning. We're very focused on that right now. We want to leverage our machine learning capabilities to automate manual processes, as well as to perform predictive analytics. Another area we're looking into is how we can make more of our architecture serverless and easier to manage.
Great. Thanks, Ryan, for sharing your architecture with us. And thank you for watching This Is My Architecture.